Alright, so I want to do a quick video here on approximations, and specifically the one famous for it is Fermi approximations. And basically, this is just a way to make some quick approximations in your head to either get a ballpark figure of something that you may have very little information about, or to even check and make sure that when you're actually doing the math out for a problem and you get a final answer, that your answer makes sense. So the idea is, say I calculate something out and I get that the answer is 150, and I do a quick Fermi approximation in my head and realize that the answer should only be, like 10 or 20, then I know that I've either messed up my approximation quick in my head or I've messed up my actual calculation. So it's a way to kind of catch yourself. And then on the other hand, if I do my math out and I get 150 and I do my Fermi approximation and I'm thinking it's 100 to 200, it's going to be somewhere in there because that's really about as good as you get. It's in the lower 100s with it. Then you feel a little better about the answer you came up with as though it makes sense. So it's really basically an order of magnitude approximation. And Fermi made this very popular because he was extremely good at this, and he used to do it a lot. In fact, one of the most famous things he did was that he apparently, when they did the first atomic bomb test, he took a piece of paper and ripped it into some little squares, and as the blast wave came past where they were observing, he dropped these little pieces of paper and he let them go, and then he watched them and he saw what like little path they followed as the blast wave came by, and very quickly from that, just in his head, he was able to approximate how strong that atomic blast was, and it turned out that he was actually pretty close to what it really was when they went back later and did more accurate calculations. He was very, very close just by dropping a few pieces of paper and watching them and doing something real quick in his head. So I think the best way to do this is just to kind of walk you through an approximation that I would do. And the reason I came up with this approximation is because my daughter asked me the other day at dinner, asked me this question, and it was essentially, we're here in Tampa, and it was how far are we from the South Pole? Now, this isn't a question that most people just know off the top of their head. And in fact, it wasn't a question that I knew the answer for off the top of my head. So in my family, we're not allowed to pull out our phones or anything like that at dinner, at the dinner table. So I had to come up with a way to figure this out there at the dinner table. So I tried to do basically a Fermi approximation. I didn't just do just the order of magnitude approximation, though that's really going to be where you want to start, is just looking at order of magnitude. I tend to, because I've gotten kind of practice, I tend to do a little more accurate than just order of magnitude, where I'm not just telling you, oh, it's 1,000, or oh, it's 10,000, or it's 100,000, or a billion, or something like that. I can usually get a little closer than that and tell you where it is, how many thousands it is, and or how many hundreds or how many millions it is. So I had to think of, what did I know? And well, the first thing I know is that I know, well, it's kind of two things. I know that the speed of light is about 186,000 miles per second. And I also know, so combine that knowledge with that light can travel around Earth about 7 times in 1 second. So real quickly from that, I said, all right, well, if I know that light can go around Earth 7 times in 1 second, which is something that I don't even remember where I learned that, but it's something I always have kind of in the back of my head for, I heard as like an example for how fast light really was, to kind of put this speed into context of this 186,000 miles per second. And I said, all right, well, if I just divide 186,000 by 7, then I'll have about the circumference of Earth. And so if I do that, I divide this out, and just doing it real quick in your head, I'm just going to do 18 divided by 7, and then I'm going to basically multiply 4 back over, because in my head I'm thinking 18 divided by 7, that's pretty easy. 186 divided by 7, not so easy. 186,000 divided by 7, not so easy. But 18 divided by 7, that's pretty easy. So in the back of my head, I make this 18 times 10 to the 4th, right? I just move this over, and I'm going to kind of hold off on this 10 to the 4th, and then in my head, I just divide this. And so you can do division in any order you want. So I just did the 18 divided by 7. It's just a little trick. I know it's not quite scientific notation, but it's close enough. So 18 divided by 7, and I just thought, that's about 2.5. Just real quick, I'm not worried about the 6. I'm not going into, oh, well, it's 2 4/7 or whatever. But it's around 2.5. There's about 2.5 of them. 7 goes into 14 twice. There's 4 left over. That's a little more than half, but again, it's about half. It's about half of the 2.5 of those. And then I have to add on that 10 to the 4th that we had there before that's still there. And so that gives me about 25,000 miles around Earth. And then I started thinking, well, all right, if this is Earth here, let's have our picture of Earth, and here's our equator. Well, going down from the equator to the South Pole, well, that's a quarter of a way around Earth, right? So like if I was going all the way around this way, it'd probably look a little better. If I would curve down here, that's a quarter of the way around the circle. So I know that going from the equator to the South Pole is going to be about 1/4 of this. So then I thought, well, what's 25,000 divided by 4? Well, that's around 6,000, right? That's, just in my head, 25,000, because 24 divided by 4 is 6, and so 25, it's a little over 6. So 6,000 and something, but it's around. We're doing these. I probably should have made these approximately signs, but it's approximately about 6,000, right? Maybe a little more than 6,000. I mean, this might be 6,200 or 300, because we also kind of dropped this down a little lower than it was. So it's going to be greater than 6,000, but still it's kind of close. And then I thought, well, where is, picture in the globe of mind, where's Florida? And Florida's kind of here. We have the United States, and it comes down over here. But Florida's kind of here. It's above the equator. It's I guess here's South America, and here's where we are in the middle of Florida. And I thought, we're maybe 1/3 of the way up. If I thought of this in my head, as we curved up around Earth, we're probably about 1/3 of the way up towards the North Pole, which would have been another quarter. So I thought, well, we're basically another 1/3 of this distance, which is this other quarter of that. So I thought 1/3 of that, that's another 2,000, right? So I took that 6,000 and I said plus another 1/3 of that 6,000, because we're a quarter of the way here, and then we're 1/3-ish of that quarter of the way up here. So it's 6,000 divided by 3, which that's 2,000. And so I just said, what's 6,000 plus 2,000? I said, all right. And I told my daughter, it's about 8,000 miles away. And 8,000 miles. I know I left all my units off this, but in my head, I'm just kind of doing these real quick. I know these are all miles, 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 miles. But basically, I came up with the number 8,000. And I said that's about how far away we were. And then, of course, my wife said, whoa, how did you, come up with that? And I, and she said, I'm going to double check that. So she broke our rule, and she pulled out her phone, and she looked up using Google Maps how far it was from Tampa to the South Pole. And I'm going to leave it up to you to Google search this, find it out, and see how close was this answer I came up with. That's all on you. And then the other thing I want you to do is I want you to try one of these, and I want you to do this without looking anything up, and I want you to just try and do this with just the knowledge you have. And it may take you a little while, as you practice these and you get better at them, you kind of get faster at picking out what things you know. But essentially what I want you to tell me is how many, again, don't look it up, don't ask anybody else. I want to know how many golf balls will fit in a suitcase. I didn't tell you what kind of suitcase. I didn't tell you how you're stacking them in there. We just want an approximation here. Is it 20? Is it, just a few? Is it on the tens? Is it 20 or 50 or something like that? Or is it a few hundred? Or is it thousands of them? Is it 50,000? Just how many can you fit in just a suitcase? Okay, so you have your suitcase and you start packing it up with golf balls inside it, right? Golf balls, golf balls. How many of these golf balls, can you fit all inside here? How many could you fit inside your suitcase? All right, that's all for now.